So our project was the flat network disaster. We were a startup that was given one router, one firewall, one web server, and one database server. Immediately, as you can see in this picture, there is a number of vulnerabilities with this. Oh, whoops, I had 8 written down, and I didn't write the last one down. But we can see that there is, let me find notes here. Sorry, I had this written down here. No. There we go. So we have vulnerability number 1, which is the lack of firewall ACLs and rules. All the systems, the firewalls are default configurations and can allow for unwanted traffic. This creates the risk that attackers can access the internal systems due to lack of port and service filtering. This ties into A.13.1.1 network controls and A.1.9 access controls in ISO 27001. Some of the considerations are high likelihood due to default settings, high impact if unauthorized access occurs, and critical risk without proper configuration. The second vulnerability is the flat network and no VLAN. We can see that every system on the network, including the database and web server, and every single one of the workstations here, is sharing the same subnet and network space. This means that any compromised device can reach the others without any barriers. This ties into A.13.1.1, which is network controls, and A.13.1.3, which is segregation in networks. This raises the risk of lateral movement and a critical impact if sensitive systems are reached. For the third one, we have the single point of failure. With only one router and one firewall, if one of them goes down, then everything fails because there is no redundancy, and especially if the firewall is an inline firewall. This ties into A17.1, which is business continuity, and A12.1, which is operational procedures. This is a high impact on availability and moderate likelihood of failure, and high risk for business operations. Vulnerability 4, there's no DMZ or proxy server, meaning there is no buffer between the internal network and the internet. Attackers can reach the internal resources directly from external resources. This ties into A8.23, which is web filtering, A8.22, which is segregation of networks, and A8.20 network security. Leaves a high exposure to external threats, critical impact of compromise, and high risk of domain takeover. The fifth is an exposed web server. 5 and 6 are similar, but they both pose their own risks. Whoops, I skipped 5, sorry. No, I just remembered it. Exposed web server. It's accessible by all internal systems. Attackers on the web server could pivot to other resources. This ties into A12.6, which is technical vulnerability management. High exposure, critical impact of compromise, and is a common attack vector. Then we have exposed database servers, which, same thing, they're accessible by all PCs in the web server on the network. Sensitive data can be accessed if any endpoint is compromised. This ties into A8.2, information classification, and A12.3, backup protection. Insecure network services is our next one. Network services are exposed and easily accessible. Attackers can target these services due to lack of controls. This ties into A8.21, which is security of the network services. And then the last one that I forgot to add on my slide here is there's no internal firewalls or segmentation. There's only the edge firewall, and internal systems are not isolated from each other. This can enable lateral movement and malware propagation. This ties into A12.1 logging and monitoring and A11.2 physical and logical access segregation. So yeah, we can see that this is a really insecure setup. And I mean, assuming that everything is default configurations, we can see that this would only get more insecure, especially if those default configurations are things like default passwords. Oh. So then the dangers of segmentation, there's the lateral movement risks. All devices on the same network have on the same subnet with no VLANs or segmentation. A compromised device can easily hop to the other devices, and there's no segmentation or barriers to stop them. Both the web and database servers are reachable by all systems within the network and any external system fairly easily. And domain takeover becomes very realistic, if any one system is breached. As for insider threat risks, any internal user can access the other systems. There's nothing stopping them from hopping from one system to the other, especially the database and the web servers, since they're all on the same subnet, and there's nothing stopping them. Privilege escalation is a bigger risk because of this, and a malicious insider can deploy malware or alter permissions. And then lastly, we have ransomware spread risks, which this allows rapid propagation of ransomware and other malware through the systems. Then lack of segmentation means that it can spread very easily and turn into an entire system takeover. And malware can reach the servers and critical systems. Firewall defaults may allow C2 communication if the default firewall rules are just too weak, and then data encryption and disruption could impact the entire domain. And then this is the risk register for this. We can see that the likelihood of lack of firewall rules is critical, the impact is high, and the risk level is critical. The firewall exists, but it uses default rules and no custom configurations. Simple mitigation for this would be adding rules to control traffic and block unnecessary ports. For the VLAN, we see that it's a high likelihood, critical impact, and high risk level. The router is operational and connects all the devices, but to fix this, we should create VLANs to segment devices and control traffic between groups. This way, we can ensure switches and routers are configured accordingly. Single point of failure is high likelihood, critical impact, high risk level. Network devices are all on and working, but we should add redundancy with multiple routers and firewalls and implement failover mechanisms. There is no DMZ or proxy server, which is a high likelihood, critical impact, and high risk level. The edge firewall exists and it's active, but it's got weak protections. So setting up a DMZ or proxy server to separate the external traffic from the internal resources and filter incoming requests could help with that. Without segmentation or an internal firewall anywhere, it's a critical likelihood and impact and a high risk. The edge one exists and is active, like I said, but we should add internal firewalls and segment the network. In this way, we can isolate the critical systems and prevent lateral movement. The exposed web server is a high likelihood, critical impact, and critical risk. Has basic OS firewall enabled, but we should really place the web server behind its own firewall and ensure access is restricted to necessary traffic only. The exposed database server is critical across the board. Once again, it has a basic OS firewall, but we should place that one behind its own firewall as well and configure it appropriately to limit access to only authorized systems and isolate it from public-facing systems. And then lastly, we have the insecure network devices. Services, high likelihood, critical impact, and high risk level. Services are running on standard ports with default configurations. We should remove the unwanted services and applications and potentially bloatware that comes with these default systems and segment the network with VLANs and restrict access with firewalls and ACLs. ISO 31000 mapping is reflected in the risk register because it applies to the risk management framework through identification, analysis, and evaluation of each risk with likelihood, impact, and mitigation strategies. And now I will pass it on to Jaden.
First, we have the VLAN plan. This is assuming that a DMZ server is now set up. So we have the user VLAN at VLAN 10, and that includes the 8 internal devices that are required, so the 8 PCs. And then the subnet for that would be 192.168.10.0/24. And for the web server, we have VLAN 20, and we name it DMZ VLAN because that would be the case with the DMZ server. And then we have the subnet 192.168.20.0.24. And then for the database server, it's the database VLAN. It's VLAN 30. Similar subnet, instead of 10 or 20, it's just 30. To take this a step further on the router, we'd do encapsulation, and we'd make it so that all the devices within all the devices on the user VLAN will stay within the same subnet address, but that's a different conversation. Next is the Firewall ACL improvements. So we'd start with making sure traffic that goes from the internet to the DMZ server would only allow TCP/80, which is HTTP, and TCP/443, which is HTTPS, and then we deny direct access to the database VLAN. And then for the DMZ to the server VLAN, we'd allow traffic from the web server to the database server and then deny all other traffic. And then for the user VLAN to the server VLAN, we'd allow only the traffic of required services or specific applications. So we'd do that and then deny direct access to the database server again. And then for the user VLAN, for traffic from the user VLAN to the DMZ, we'd allow only HTTP and HTTPS. And then for the inter-VLAN default policy, we do deny all, and then we permit by exception only. So only the required services that we exclusively allow would be allowed to send traffic. And then I'll move it on to pass over to Hayden.
Okay, sorry. I think we're ready. So the next up is the European Commission mobile platform data breach. Some of the key details is that zero-day vulnerabilities in mobile device management systems enabled unauthorized access. These consisted of 2 CVEs, the CVE-2026-1731, which is a code injection vulnerability, CWE94, that exploited bash arithmetic expansion within the in-house application distribution component. Attackers can send crafted HTTP GET requests to the MIFC App Store FOB endpoint. This enabled execution of arbitrary OS commands with application level privileges. Application level privileges due to improper handling of input in the backend bash scripts. And then the other one was CVE 2026-1731. This is another code injection vulnerability that affected Android file transfer configuration features. Attackers can exploit improper input validation in the backend logic and manipulate HTTP parameters such as ST or H to inject and execute malicious code on the system. Using preventative controls and zero trust segmentation, we found that those were insignificant. My notes for that one. I'm sorry. I'm not used to slideshows here. Preventative controls and zero trust were insufficient. Data exfiltration occurred due to governance and access weakness. There was no EDR to stop the data exfiltration from happening. They discovered it only after it happened. Vulnerability management and compensating controls were lacking. Proper vulnerability management could have helped with this by notifying them that critical systems in their network were vulnerable with these CVEs that were actively being exploited in the KEB catalog. The incident was detected and contained within hours, and within a week they announced the breach. Governance failures highlight the need for structured AI and security controls. And ISO 27001 and 42001 frameworks address the lifecycle and risk management gaps. You're muted, Jaden.
Sorry. Okay, so for CVE 2026-1731, it was a beyond trust remote code execution flaw, and it was in their remote support and their privileged remote access, and it comes from an operating system command injection weakness, and an attacker can send requests directly to a vulnerable service, and it causes it to run an arbitrary operating system commands without needing any valid credentials to do so. And so they issued the security advisory and released fixes for it on February 6, 2026. The patch was applied automatically to cloud and SaaS instances by February 2nd, 2026. But self-hosted customers were required to manually update to patch versions to mitigate the risk. There was when it comes to vulnerability management, the failure occurred due to a lack of timely patching in the self-hosted environments. So that allowed attackers to exploit the already known flaws. Asset inventory or exposure identification gaps are also something that helped in this vulnerability being used. It was a result of organizations running internet exposed remote access appliances without identifying or isolating critical attack surfaces. There was zero trust architecture missing. The exploitation, the consequences of the exploitation of this vulnerability were made worse because of the lack of zero trust principles. Because a lot of the time they had trust being implicit, or the remote access tools were exposed, and there was no micro-segmentation or strict identity and role access policies. Risk communication was ineffective as well. even after vendors disclosed and CISA, it was on the CISA KEV listing. A lot of organizations didn't communicate urgency internally across their teams, and so this enforced rapid remediation. So there was a lack of communication, and then security advisories didn't translate things in a timely manner into operational actions. And so risk assessment did not sufficiently identify internet exposed remote support appliances as high impact technology, and the impact or likelihood scoring didn't appropriately reflect the how critical the unauthenticated RCE was, and risk treatment planning lacked urgency triggers for critical third-party exposures, and also risk management processes for self-hosted remote access wasn't robust or timely, and so it just overall was a mess. And so yeah, those are kind of the key things about this vulnerability. And then for ISO 27001, oh, I think that's the wrong number. I think it's
42,001.
42,000.
I'm sorry about that.
It's all right. So this ISO exists for AI governance, ethics, accountability, and lifecycle risk management. So it's AI, because AI is being adopted at such a high rate. There's little to no governance, and so organizations are deploying machine learning models, generative AI systems, and autonomous decision-making tools without the proper government. And without the proper governance, AI systems can make biased decisions or produce harmful outputs or violate privacy laws. So ISO 42001, it exists to create formal management controls for AI. So because AI systems are unique and they learn from data, and behavior can change over time, it makes traditional governance models inefficient. And so AI specifically introduces new or unique risk, or it's risks that already existed, but they show up in a unique way. And so, for example, there's general bias that can happen, a lack of real reasoning or explanation for what the outputs are, and a model drifting or poisoning. So algorithmic bias occurs from biased training data and can result in discrimination or decisions that unfairly impact certain groups. And then automation bias occurs when humans put too much trust in AI decisions and they fail to question any incorrect outputs that AI gives. AI systems can be complex and opaque. So when organizations rely on AI to automate decisions, a lot of the times they can't explain why a customer received a certain response, and this can result in legal risk later or decreased consumer trust. Model drifting occurs because real world data is always changing, and so the data being given to the AI needs to change as well, and not to mention the performance of the AI model can degrade with time, and so this poses a safety risk. It can pose extra financial cost, or it can cause incorrect decisions to be made, which again brings up legal issues as well. Model poisoning happens from attackers when they manipulate or change the input or training data, or the input data from the AI. And yeah, pass it back over. You're muted.
Thanks for that. Move some stuff around. So I have some key differences here. Similar to ISO 27001's Annex SL high-level structure, ISO 42001-2023 follows the same 10-clause framework aligned with the Plan, Do, Check, Act PDCA model. Structural alignment enables organizations with an existing ISO 27001 information security management systems to effectively integrate an artificial intelligence management system, AIMS. Some of the key similarities between the two are that ISO, those are differences. I'm going to start with these similarities. Some of the key similarities is that they both follow the same 10-clause structure. This includes context, leadership, planning, support, operation, performance, evaluation, and improvement. Annex A controls, they both have the Annex A control framework. ISO 27001 provides a broad set of information security controls, while ISO 42001 includes controls specifically tailored for AI governance. And both of them have SOA. They both require a statement of applicability to justify which Annex A controls are implemented and how to address the identified risks. Some of the key differences is that ISO 27001 governs information security, while 42001 specifically governs the AI lifecycle and governance. 27001 focuses on data protection and system security, while 42001 addresses AI-specific risks, like Jaden mentioned, bias, transparency, model behavior. ISO 42001 also includes additional annexes instead of just Annex A. There's also Annex B, which is implementation guidance, Annex C, which is potential AI risk sources, and Annex D, sector-specific guidance, which provides deeper contextual support for AI risk management. And unlike ISO 27001, ISO 42001 covers the entire life cycle of the AI, from data acquisition all the way to model development, and then to its eventual retirement. An example of a recent failure with AI governance would be the Moltbook breach. I'm sure most of us have heard of that by now. Earlier this month, Moltbook disclosed a major data breach. It was the Moltbook was known because they were the first. So I can see. They were the first platform that was developed primarily through AI-assisted coding practices, known as vibe coding, with minimal traditional development oversight. It illustrates the risks associated with over-reliance on AI-generated infrastructure when governance, validation, and security controls are insufficient. It resulted from a critical misconfiguration in the Supabase backend environment, where public read and write permissions were enabled and row-level security RLS policies were not implemented. This misconfiguration exposed sensitive data and API credentials, which showed failures in lifecycle validation, access control governance, and deployment oversights. It does align with several of the ISO 42001 Annex A governance control objectives. A.3, internal organization. The goal is to establish clear roles and responsibilities for AI system management. 'Cause And the failure here was that it was AI generated code without defined accountability, security review, or approval authority. A.6, AI system lifecycle. This defines the requirements and conducts verification and validation prior to deployment. And the failure here was backend configuration lacked security validation, which resulted in public database exposure and absence of RLS controls. 8.4 Resources for AI systems. This aims to document and manage technical resources, tooling, and computing assets. And the failure here was exposure of approximately 1.5 million API tokens, including OpenAI and AWS credentials. Then there was 8.9 Data for AI systems. This ensures data quality, protection, and secure handling of AI-related data environments. The failure here was a compromise of approximately 35,000 email addresses and private messages. And then lastly, we have 8.8, information for interested parties. This establishes reporting mechanisms and structured incident communication. And the failure here was that breach detection relied on external researchers rather than internal monitoring controls, as the breach was not made aware to the public until, they weren't aware of the breach until researchers announced that they discovered it. And with that, that is the end of our presentation. Where did it go? Thank you so much, Melissa.
Okay. How take a scenario, you both are running an AI organization like OpenAI or any other organization who works with LLM models. How you are going to make a new AI LLM model which is used in cybersecurity? It follows the ISO 42000 as well as ISO 27000.
Can you rephrase the question real quick? Sorry.
You both are running an AI company, or you are generating and creating AI LLM models. Now you have a project where you have to create a AI model for a cybersecurity company, but they have a requirement that you need to comply with ISO 42000 as well as ISO 27000.
I would say that the first step would be going with the ISO 27,000 controls first, since they're broader and wider, and then ensuring going over it again after creating the topology and confirming that it also aligns with the ISO 42,000 controls and going from there.
Okay. And what about how will you manage the 42,000?
Well, that one covers the entire life cycle of the AI development. So you would use it to ensure that every step of the way you're properly configuring everything. So there's as little vulnerability as possible, since that one is specifically for the entire life cycle and development of AI.
And ensure your company policies reflect the expectations given by, what was it, 42,001, I think.
In your lab, you have one web server and one database server. Now you are using a traditional SQL database server. If we switch it to non-SQL or any other type of database, will it affect your entire lab?
I would assume so. Assuming you're switching from like an SQL database to a Mongo database. I know they both have different setups and configurations. So I would assume that it would take a detailed look and making sure you're staying compliant and understanding both databases and how they work to prevent, because they both have their own vulnerabilities, such as SQL injection and MongoDB bleed.
Yeah, Ronnie, what is it?
Okay, I have a question on which were they presenting the ISO 27001 that was released on 2022, or were they demonstrating the whole concept of ISO 27001 concept?
We tied the ISO 27001 controls to the vulnerabilities on the packet tracer topology. I do have, I can show real fast, another picture somewhere of the network topology that shows the vulnerabilities included to us. Maybe I don't. I thought I did. Is this one it? Loading, sorry. Why are you doing this? Trying to find it. 3, 2. I guess I don't have the other picture that I had made. I thought I did.
I might have it, one sec. The one with the notes.
Yeah, the one that had the notes rather than the one that was a little cleaner for the slideshow that I used. For some reason, it's not letting me open the pictures in my drive. I have the one that I started it, but I don't have the finished one, even though I took a picture of it. I thought I sent it to you. Or I thought I put it in the drive.
No, I think you put it in the Discord. Hold on.
Sorry.
Yep. I can't.
That's not the finished one.
Yeah, I don't have the picture. Oh, I have the started picture, but I don't have the official one. But yeah, all the ISO 27001 controls were tied to the different vulnerabilities. Because if you this is the site that I primarily used to map them, was this one here. It lists all of the controls. It did come out in 2022. That's what you were asking. But then otherwise from here, it separates it into organizational controls, people controls, and technological controls. Does that answer your question, Rulene?
Yes, brother. Thank you.
Okay.
Okay. Now some questions are left. The firewall that you configure, what if it was a ACL firewall that you configured? How is the attack scenario then?
Wait, configured an ACL file instead of a what?
What firewall did you configure? It was ACL or just ordinary one or some other firewall?
Do you want me to get that screen up for you?
Wait. Sorry, can you repeat the question one more time?
Which firewall did you configure? Whether it was some other brand, other type, or whether it was ACL.
I based it off of ACL.
Okay, it was an ACL.
I based it off of the ACL configurations and what the what their like when I did the when I did the research, I based it off of ACL improvements and how that functions
Okay.
mostly.
Let's assume you have double or triple the numbers of your endpoints as well as your router and firewall. Now you have 3 firewalls, 2 routers, and approx 50 internal system. And each firewall is configured and managed differently. As a hacker or as a blue team, how will you monitor them? Or as a hacker, how will you gain access to the internal system?
Did you say we have 3 firewalls now, and you're asking
Yeah,
how we would set it up and monitor?
yeah, 3
Um,
firewalls and 2 routers.
Well, if they set up different, chances are it makes sense to. Are they part of like different? You said how many routers now?
2
Two.
routers and 3 firewalls.
Okay.
I found the old topology that I had done. If having the image would help explain it. So this was it with the misconfigurations. So I would say, oh, sorry.
Go ahead. You go ahead.
I was going to say, for starters, I would put firewalls in front of the database and the web server, and keep one between the internet and the intranet. As for the second router, I would. That one I'm not entirely sure.
For the second router, given that we have 8 internal devices, we could
No,
probably
your internals, with the increase in router and firewall, your internals are now approx 50.
50
Yeah.
or 15. Okay, 50. Then it's probably best to split it, have the servers on separate routers and then split the internal devices evenly. And then since it's 3 firewalls, I think having them before this in front of the servers don't make sense.
Okay. What about your research? The Beyond Trust RCE. If this RCE happened to your organization that you are being part of, how would you prevent it?
Well, I'd start with patch management. So I'd make sure I have for Beyond Trust, for the remote support and the privilege, remote access, everything's updated. And then I'd probably make sure that I have alerts set up, so anything weird going on the network I can see, because that was one of the reasons why the vulnerability worked so well, because alerts weren't set up well. And then also I'd make sure one sec. Oh, I'd also make sure I have manual patches set up anyways. So when a vulnerability like this comes out, I already have the system's already updated and there's not much to worry about aside from just making sure that you haven't already been affected by the vulnerability without knowing. And I guess that'd be it. Yeah.
If you want to map your, which was the second research, the European Commission mobile platform breach, if you would have to map it to MITRE attacks, where would you map it? Just in a general direction, not in a specific way, just in a general.
For MITRE attacks? Let me get my notes here. So they definitely moved laterally through the environment, and they also elevated their privileges. So those are two immediate things. And then they also were injecting code into the MDM. And then there was also data exfiltration. I think that about covers the main tactics that were used. Techniques there was injection to get in. They escalated their privileges. They established persistence through administrator level controls, and they were able to exfiltrate the employee contact information, and then they were able to move laterally through the system with stolen credentials and harvested data. They also use this information for spear phishing, vishing, and other internal network compromise.
Okay. One last question. What are the IOCs for this breach?
So immediately you can definitely, if there was proper logging, they would be able to discover that there were injections being put in to their systems that would show up. I didn't see what database they were using, so I don't think it was SQL specifically, but they would have seen that. Otherwise, the exfiltration, they would have, if they had proper EDR, they would have noticed that. And in January, they did discover a few artifacts that related to the intrusion and containment, but I don't know what artifacts exactly they found. I would imagine there were commands that they would be able to find in the logs that showed commands for taking over administrator accounts and moving laterally through the system and various things like trajectory traversal, directory traversal.
Okay.
Those
Now,
are just a
Jaden.
few off the top of my head.
Okay, thank you, Jaden. And now, Jaden, one last question for you too. What are the IOCs for Beyond Trust?
The what? Sorry.
IOCs, indicator of compromise.
Uh, 1 second. Sorry. Uh, trying to find it in my notes because I know I put it in there. I don't currently. There'd be suspicious or unusual request to the service, so to the remote support service or from the remote support service. So it'd be because it's an OS command injection weakness, so there'd be suspicious request or what's the word I'm looking for? I can't think of it. Suspicious isn't the right word, but I can't. Anomaly. Yeah.
Anomaly.
Yes. Thank you. Those requests to a service or a vulnerable service, and then you'd see that like operating system commands are being run that either you know for a fact that aren't being run or like arbitrary ones that aren't typically run.
Okay,
You
thank you.
likely get. Oh, sorry.
Okay, thank you for that.
I had one more thing to add real quick. Another IOC for mine would have been the malicious HTTP requests in the web logs as well. So a lot of logs because they had the malicious crafted HTTP requests on exposed endpoints. Just wanted to add that last bit in before I forgot.
Okay, then. Thank you for your presentation. Anybody have any last questions before we move to another people?